Good afternoon, everyone. My name is Jane Pillai, and I'd like to welcome you back to another Tech Talk in our series sponsored by Pressable. Today, we have the pleasure of welcoming Ashley Bisram to give us a brief talk about message brokers. So without further ado, I'd like to pass it on over to you, Ashley.
Thanks so much, Dan, for that wonderful intro. I do want to thank so much to Pressable for sponsoring our talk today. Once again, my name is Ashley Bisram, and I am a software engineer at Kronos, which is an open source monitoring tool. And I'm here today to talk to you about Amazon Symbol Queue service and message queues generally. So just to get us started and primed up, I'm just going to give you a little overview of what we'll be talking to today. First off, an introduction about message queues and the different types of message queues in order for us to dive into Amazon SQS. We'll get into a real world case study that deals with Amazon SQS. Finally, no worries, we have a little quiz at the end, but nobody's getting any grades. It'll just be to see if you guys are paying attention. And then last off, we'll wrap up with a Q&A, so you can ask me any lingering questions you might have regarding SQS or anything else. So let's get started with our introduction. What are message queues? So here on our slide, we have a little diagram of a message queue. And a message queue is a system that allows different parts of an application to talk to each other asynchronously by passing messages through this queue. So here we have the producer on the left-hand side of the screen, which sends a message over to the queue. And then from the queue, the consumer receives that message. So think of a restaurant takeout order system. A customer places an order, which is like a message. The chefs prepare them in the kitchen, which is like the queue. And then orders are picked up when they're ready. Next, we'll dive into different types of message queues, and there are quite a bit, so hang here with me. First, we have the standard queue, which is all about speed and scalability. It allows messages to be processed quickly and in parallel, but there is a trade-off in that messages might be delivered out of order, or there is a possibility of duplicate messages. This makes it really great for high throughput systems such as log processing, background tasks, or notifications, where the order isn't critical, but the performance is. But next up, we have the FIFO queue, or FIFO queue, depends on how you say it, which just stands for first in and first out. This queue guarantees that messages are processed in the exact order that they were sent, and it does prevent duplicates. Because of these guarantees, FIFO queues are ideal for use cases such as financial transactions, e-commerce, order processing, and workflow automation, where processing things in that right order is really crucial. Next up, we have the priority queue, and although this isn't supported with Amazon SQS natively, other messaging systems, which we'll touch on in a bit, do allow messages to be assigned differently to those different priority levels, which means that high priority message, such as from a VIP user, might be processed before lower priority ones. And for a real world example would be a customer support system where an urgent ticket might need to be addressed before regular ones, or in emergency alert systems, critical notifications can't really wait in line behind less important ones. And then finally on this slide, we have the dead letter queue, which is supported by Amazon SQS. And it's not a type of queue you actively send message to. It is more of a safety net for failed messages trying to get through the system. So if a message keeps failing to process after multiple retries, it gets sent over to this dead letter queue for later analysis. And it helps to prevent infinite message loops and lets engineers debug failures without losing important data. So just to wrap it all up, these are different types of message queues. If you need speed, go with that standard queue. If the order really matters, use the FIFO queue. If some messages are more important than others, a priority queue is the best choice. And to prevent any failures from slipping through your cracks, always set up a dead letter queue. But let's get into how these queues can be applied in message brokers. So a message broker enables applications to communicate and exchange information by translating messages between different messaging protocols. They can act as an intermediary that allows senders to transmit messages without knowing who the receiver is, their status or location, and it promotes decoupling within systems. Message brokers can utilize those different types of message queues that we discussed to provide reliable message storage and guaranteed delivery, and ensures data ordering and integrity. There are other core features of message brokers that we're not going to be definitely talking about today, but we will be touching on the message queuing aspect of them. But there are other message brokers that have a publish and subscribe model, as well as message persistence, which are some other core features of message brokers. So on the slide here, you see that it's divided into traditional and modern message brokers here. So on the left-hand side, you see RabbitMQ and Apache ActiveMQ. And if you remember from the previous slide, I talked about that priority queue, which is not supported by AWS SQS. But these two different message brokers do support that type of message queue. And on the right-hand side, we see modern message brokers such as Apache Kafka or AWS SQS, which we'll be diving into today. One of these ways to distinguish when to use a traditional or a modern message broker is dependent on your type of application. So you might want a traditional message broker when you want to support those priority queues we talked about, or for simpler applications with moderate message volume where there's easy setup and basic queuing functionality that are just sufficient for your needs. But if you have a large application that might need to handle large amounts of volumes of data with high throughput, or if you need to ensure data durability with message replay capabilities, modern message brokers are your best bet. But let's dive into Amazon SQS, this modern message broker. So this is just a little takeaway from the Amazon Developer Guide on their website. The Simple Queue service, which is Amazon SQS, it does offer secure, durable, and available hosted queues that allow you to integrate and decouple different services. So Amazon SQS does offer the dead letter queues that we talked about before, which is really helpful for debugging, and also cost allocation tags. And that's really helpful to organize and identify your SQS queues for such as metadata tags that you can identify the queue's purpose or the environment. And it's really helpful when you have a lot of queues. And that's something that you can configure in SQS as well. And just to kind of wrap up here on this quote, the main takeaways is that it integrates really well with the Software Developer Kit with AWS, which is a set of platform-specific building tools for developers. And just to think a little bit high level about SQS, there are different problems that it does solve by preventing app crashes due to high traffic. They also help services communicate without being directly connected. They also improve scalability and reliability. And so let's dive in a little bit deeper on how Amazon SQS works. Similar to the queue diagram that we saw before, there is a producer, a queue, and a consumer. So the producer is who is sending messages to the queue, and then our queue is where we are storing those messages until they're processed. Next, we have our encryption here with SQS, which is optional in order to make sure that you have a secure environment, but ultimately it is the consumer that retrieves and processes those messages. And some of the types of SQS queues are the standard queue, which has unlimited throughput, which once again, it may deliver messages out of order, and the FIFO queue, which ensures the first in, first out processing, but it does have the limited throughput. And some other key features of Amazon SQS is that it's fully managed with Amazon AWS, all of those integrated services. There's no setup headaches here. It's super scalable because Amazon SQS can handle millions of messages per second. It's super reliable with ensuring message delivery, and it is secure because it integrates with Amazon's identity and access management, which enables you to securely control access to your AWS services and resources with your users. And now let's get into a real world case study. AWS SQS, it does have a lot of customers such as BMW, NASA, but we'll dive into their relationship with Capital One. So Capital One utilized SQS in order to migrate applications from core banking applications to the cloud. They also used SQS in order to improve reliability, as SQS helps to ensure high availability and reliability for applications. Next up, they also used SQS with reducing complexity, as it does help simplify administrative complexity and overhead. Capital One also used SQS to help process event-driven applications, such as separating the front end from the back end systems. And lastly, one of the big reasons that Capital One utilized SQS was for scaling their applications up. You can allow multiple workers in an auto-scaling group to scale up and down based on the workload. And there's also tons of other AWS services that are used by Capital One, such as EC2 for their computing, S3 for data storage, Aurora Global, which is used to reroute traffic in the event of a regional failure, and also AWS Lambda used to process messages in SQS. There's also this video where they talk a little bit about this migration to the cloud. It's 40 minutes long. We're not going to be watching that today, but you'll have access to these slides later on if you'd like to take a look and watch that video yourself. So we'll just get up next into our reinforcement quiz. So don't worry, once again, no grades at the end of this, but you're just going to be shortly receiving a pop-up on the Zoom screen that will have 3 different multiple choice questions regarding Amazon SQS or just queuing in general. So without further ado, we'll shortly be seeing that poll pop up. I see that. Great. Thank you so much, Dan. So once you have a minute, just take a look. I'll just read those out loud for folks who might not be able to see that poll. So the first question is, which type of SQS queue guarantees messages that are processed in order? There's the standard queue, the FIFO queue, both or neither. Next up, we have you're building a ride-sharing app like Uber. How would you use SQS? And there's a few options there as well that you can choose from. And then finally, which AWS service would you likely use with SQS? And there are a few options there, but I'll leave it up to you guys a minute or two to fill out that poll. Awesome. I'm going to see on my end how that is going. Perfect. Jane, how are we doing with those poll answers?
So we are at about 11 total. I think our third question is unfortunately a trick question, just to let you
No,
know.
it's all
But
right.
other than that, we're doing pretty good. We are at 13. Do we want to go ahead and close it out?
Yeah, let's close it out. Can we display those results back to them? That'd be awesome. Great. Okay, so let's go and debrief this quiz with everyone. So the first one, once again, which type of SQS queue guarantees messages are processed in order? We've got a lot of folks here for FIFO queue. Once again, that is a first in, first out, which is how you make sure that those messages are processed in order. Great job, guys. And then next up, we have that question. You're building a ride-sharing app like Uber. How would you use SQS? And then we have the majority of folks answering to queue ride requests and process them asynchronously. That's awesome. That is the correct answer because those queues do allow you to process those ride requests asynchronously. I see that there is matching drivers and riders in real time, so SQS doesn't have the synchronous nature to be able to do that, but that is a good guess. And then video streaming, once again, we aren't able to, with SQS, do things in real time, so it isn't that there. But great guesses all around. And which AWS service would you likely use with SQS? Similar to Capital One, actually all of these services here can be utilized with AWS SQS. So all of you are are winners with that question. So great job, everyone, in answering and participating. I really appreciate it. And I hope you learned something today. I just want to share some resources here and just wrap up here. If anybody has any questions, I'd be happy to take them at this time. Thanks again.
Jocelyn, go ahead.
Wonderful job, Ashley. Very informative and great technical communication. I have a question. Can Amazon SQS be used in real-time applications, for example, like chat systems?
Yeah, that's a great question. And I think it also does hint at that Uber riding question that we had on the poll about some folks thinking about real-time synchronous matching with riders. So while it is possible, SQS does have an inherent latency, which is the delay before a transfer of data, which begins following an instruction for its transfer. So I would recommend for real-time systems such as like a chat system, it might be a better bet to use WebSockets, or if you want to use AWS service. I've heard Kinesis is good for streaming services like that. I can drop some resources in the chat if you guys are interested in looking into more of those real-time applications and different tools that you can utilize for that. But yeah, even though it's possible, once again, there is that latency issue. But thank you so much for that question, Jocelyn.
Thank you so much for answering that. Thank you.
Awesome.
Hey, Ashley, thank you for the amazing talk. I'm sure we've all learned a lot from this. And I'm just curious, you mentioned earlier about traditional message brokers and modern ones. How does SQS compare to another modern message broker like Apache Kafka? Thank you.
Yeah. That's a great question. Thank you so much. So, although AWS, SQS, and Kafka are both modern message brokers, SQS is fully managed, it's very simple, and it integrates well with AWS, which is a huge plus for customers who might be utilizing AWS services already. Kafka does offer some advanced features like event streaming and persistent message storage, but in terms of the easy setup, AWS SQS is definitely the way to go there, but it depends on the priority for the application. I was actually doing some research about Apache Kafka versus SQS earlier on, and there's this great article on Stack Overflow that I will post also in the chat if anybody is interested in looking it up. It also has some distinguishments between SQS following that queue, and then Kafka following something called a publish subscriber model, which is something that can be seen in other message brokers, but not necessarily in Amazon SQS. But if you are looking for something similar to that publish subscriber model that is native to AWS services, I'd recommend SNS, which is another AWS service that might be able to do the job. But yeah, it definitely is not equating Apache Kafka to SQS, but there are some other alternatives out there if you want that kind of event streaming and persistent message storage. But thank you so much. I hope that answered your question.
No, that does. Thank you for being so resourceful. Thank you for your insight.
Thank you so much. I think that might be all the time we have today for the Q&A, but I have this QR code if you want to connect with me, ask me any questions, feel free to scan it. And lastly, I do want to thank you all so much for your time today, and thank you so much once again to Pressable for sponsoring this talk. And I hope you all have a wonderful rest of your day and a great weekend ahead. And back to you, Jan.
Thanks so much, Ashley. Thanks for that informative talk, and thank you to everyone for coming out this afternoon. And we'll see you at the next one.